Welcome to the Incremental Threat Modeling talk. The idea behind incremental threat modeling is to stop the teams from trying to boil an ocean. Before we dive into this topic, a little bit about myself and why it's so important to me. Towards the end of my stint as software developer and architect, I became more and more involved in the process side of things and how to go from waterfall to agile. Not loud enough? Sorry. How to introduce security into agile life cycles, and when you do that, you inevitably struggle how to fit security activities into tight incremental life cycles that don't have setup phase. And now as a consultant, okay, I do a bit of traditional pen testing, but because of my background, I mostly work with the shift left part of the life cycle, architecture reviews, code reviews, and threat modeling, and I really like to do threat modeling. So sometimes when I do it with the team, at the end they go, yes, it was very useful, we have this threat model. Unfortunately, we will not be able to keep it up to date. And I ask why? Because we don't have time to do that for each iteration. We are agile, we have half a day to change between iterations for everything, for demo, retrospective, next planning meeting. Sometimes we only have a couple of hours. No way we can do threat modeling before each iteration. Sometimes instead of doing a threat model for a specific project, I do general training, teach people how to do threat modeling themselves. And then I hear another thing that makes me quite sad. They say, that's very interesting. I can't wait to start doing it on my next project. Unfortunately, I will have to wait. Why do I have to wait? Why can't you start it right now? Because my current architecture is too convoluted. There is no way I would be able to threat model it. No, next project. We were promised. We will be allowed to do it perfectly by the book with all the security practices. I have the skills, but unfortunately I have to wait for the next project. So the purpose of my talk today is to basically demolish these two excuses, to show that you can do it on project with existing architecture and you don't have to wait for the next perfect greenfield one. Now, the way we're going to do it, I will quickly explain one flavor of software-centric threat modeling. Then I will introduce our example and we will do a walkthrough in real time how to threat model a new feature. Then I will do a complete disclosure. There is a slight sting in the tail in this whole idea of incremental threat modeling. And we will have time for questions and answers in the end. So anyone here done software-centric threat modeling? Using Stride? Okay, so it will be a very quick recap because most people are familiar. First of all, threat modeling is a structured method for identifying weaknesses at architectural level. Before you even started to build your software, you can find likely attack patterns and defend against them before you build software with these weaknesses in. There is lots of free material online how to learn to do that from OWASP. There are good books. If you want hands-on training, there are training providers, but plenty of opportunities to learn it online for free. So 3 steps. First, we need to decompose our architecture. Then, using these diagrams, we will search for threats using a structured method called Stride. And then when you have a list of threats, you need to prioritize them, but that's out of scope for today. So quickly, what are these data flow diagrams? Different types of components, each has distinct graphical shape. Everyone does it like that, so you should be doing it like that as well, so your diagrams are compatible with everyone else. They are conceptually, they're not state machines. They are not sequence diagrams. Sometimes people start struggling. They're trying to express if then else. They're trying to express first this happens, then something else must happen. You cannot with these diagrams, so don't try. Of all the elements in the diagram, the data trust boundaries are very important. I will be going on a lot about them in my example. It's important to put them in the right places because most interesting threads will be found on the data flows that cross trust boundaries. That's why when we are time limited, we will first go after those. That's why it's important to put them correctly and not miss out on all the trust boundaries in the model. After we have the model, we can apply STRIDE, and it's a description of 6 families of threads. Each family violates one of the security properties. STRIDE is just a mnemonic, and it's not a classification. It's not a field guide to the birds of Britain. I've seen it, these are its spots, this is its big shape, therefore it's this kind of bird. No, it's not for classification. It's kind of mental scaffolding to help us go through our diagrams and identify hypothetical threads. So for each tuple in the diagram, source, destination, data flow that connect them, we will go through this table and we will think, does spoofing apply to this data flow? Yes, let's record the thread. Does tampering apply? Yes. And if you come across something and you're not quite sure, is it best captured as information disclosure or is it best captured as spoofing because attacker tricked us into sending data to attacker-controlled destination? Don't waste an extra second arguing how to record it. This is not for classification. So let me introduce the example, and I will introduce it in a special way. First, I will explain the existing architecture of the hypothetical application, and I will explain a feature that we are planning to add. And then we will pretend that you didn't see it and that you don't know the threat model for the existing part. Like if there are any Harry Potter fans, it's like we will pretend that someone cast Obliviate and you forgot the existing threat model. And then we will model new feature in real time. So this is an example, a very, very simple architecture. Simple but not ridiculous, like the world is full of applications like that. We have some kind of web application where without logging in, you can read content. If you have an account, you can add and modify content, and it's served by SQL database at the backend. So simple but not ridiculously simplified. And a new feature is proposed, which is quite popular in this type of application, analytics, business analytics. So let's say we are an agile team. We are in a planning meeting. And this is what our product owner says. We are going to use a third party providing analytics technology. They're going to host data warehouse on their infrastructure. And there will be also a reporting server on the infrastructure. They will give us licenses to use some kind of analytics app, web-based analytics app. This app queries the reporting server and our users can see the reports. The only thing we need to be in-house as a team, we need to build some kind of aggregator process that will read the data from our database, aggregate it, and upload it to data warehouse. They provide API. All very typical feature in this kind of applications. So if we had a threat model for existing architecture, the one you've just seen, we would just add new components and new data flows for this story, but we don't, right? And our existing architecture is just a legacy blob. You have seen what's inside it a minute ago, but let's pretend you didn't. This is where Obliviate happened. So assuming that the real architecture is much more complex than the one I just showed you, we really don't have time to do a full thing right now. Like, I'm not setting up a strawman argument. I'm not saying threat modeling is simple, everyone has time, just do it. No, really, on a big, realistic, complex system, agile team wouldn't have time to just do the whole thing in the first iteration after they learn to do threat modeling. No, it's not true. What I'm saying is this complexity shouldn't stop us from modeling new features. So we have legacy blobs that represents existing architecture. We have a story from product owner. Can't say fairer than that every team should have at least that. If they don't have a whiteboard on which they can draw a circle and say this is our legacy blob, then they should get a different meeting room with a whiteboard. And if product owner can't tell them story on this level, then frankly, they have bigger problems in their process than just the lack of threat modeling. So I think it's a very fair setup. If you want to check how long it takes to threat model this new feature, you can get your phones out and don't go on Facebook, please start timer. We can check how long it takes. So first thing, we need to identify which existing components are involved in this story so we can tease them out of the blob. And reading the story, it's pretty obvious that only our database is involved. So that's the only thing we need to show explicitly. Do we need a trust boundary between them? No. We know that the database only interacts with other internal components in the same trust boundary as everything else. It may be that you have segregated network, which is a good security practice, and your data layer is behind firewall from everything else, which is good, but you don't show firewalls explicitly in these diagrams. They are mitigations to threats on data flow. They are not elements of the model as such. Next, we need to identify what needs to be added. Again, the story makes it pretty obvious. We need to add aggregator process that reads from our database. Now, you could choose to show a data flow in the other direction because data doesn't start to flow magically. There will be SQL select going first. Or for simplicity of the diagram, you can concentrate on the idea that logically it's just read-only flow essentially. You could show SQL select if you prefer, doesn't hurt. Does it need trust boundary? Still no, for the same reasons. Next step, aggregator uploads data to the data warehouse. And this is where we finally need a trust boundary because it's hosted on somebody else's infrastructure. Reporting server within same trust boundary of the third party, no problem. And then we have analytics user. Does this user sit in the same trust zone as everyone else? This is where we need to ask clarifying question from product owner. Does this user have to be on our corporate network to use this application, or can the user be anywhere else on general internet? If the user has to be on our corporate network, this is how the model would look. He is in the same trust zone as all of our other components. If, however, the product owner says, no, we are targeting our salespeople with this analytics, they travel, they need to be able to use it anywhere on their travels, then we need another trust boundary to separate our own infrastructure from general internet, and analytics app will sit outside of our internal trust zone. So this is job done with diagramming. How we know it's job done? If you read on threat modeling theory, it says you are done building diagrams when everyone agrees more or less that they tell the story. And with incremental, it's much easier because we start with a story. It should be reasonably easy to agree that our diagram reflects the story. When you start on a big system doing full threat modeling from scratch, actually it's much more difficult there to even agree what kind of stories the system represents. So with Incremental, we are lucky. We have a story, we can build a diagram, and hopefully the team can, in a reasonable amount of time, agree, yes, it tells a story. Now, what do we do with the diagrams? We apply stride to get threads out of it. How you do it? You can use a threat modeling tool that analyzes diagrams and auto-generates threads around your diagram. And if you build a good set of diagrams, you will get a good set of threads out of the tool. On the other hand, it's garbage in, garbage out. If you didn't build good diagrams, you won't get good threads. Or you can do it on a whiteboard, applying stride mentally. Either way, it will be a limited, manageable set of threads involved in this feature. Why is that? Because they will be concentrating around one new component and one new data flow. So let's quickly look at these threads, right? Spoofing will tend to take a shape. We have source, destination, data flow between them. Spoofing will be, how do we know the source of the interaction is who it says it is? And how do we know the data goes to legitimate destinations that the attacker didn't trick us into sending data somewhere attacker controlled? Tampering and information disclosure tend to go hand in hand, and they usually relate to security of data in motion. Repudiation is self-explanatory. Denial of service as well. The problem with stride is not everything is covered by stride. For example, privacy threats are not covered. You have to think about them outside of this model. So we have a list of threats, and some of them will be dealt with immediately. For example, if we say, we know that the file upload, data upload will be implemented over HTTPS, and we will have mutual authentication, then immediately spoofing, tampering, information disclosure threats disappear. The other threats we cannot deal with during this planning meeting. We just have to take a note and move on to pay attention to them during development. For example, we are not designing our aggregation algorithm during the planning meeting. We just need to take a note that it needs to be resistant to reverse engineering. Some of these product owner will need to clarify with the legal. Did they go through third-party documentation? Do they give reasonable SLA to us? Sometimes you need to consult company-wide privacy guide. Hopefully you have one. The one that's GDPR compliant and tells you, do you need to change your notifications that you present to the user when they log into application. But it doesn't have to be decided during the planning meeting. You just need to take this short list of threads, and some of them will become part of requirements for the story, some of them for product owner to take aside and consult other people. But essentially, this is our incremental threat model done. You can stop the timers, and it should be something like between 10 to 15 minutes. Now, you might have noticed two little sleight of hands here. First, we don't have one feature in the iteration, right? Usually the team has several features depending on the velocity. So how does that work? For most of these features, it will not take 10-15 minutes. It will take you 10-15 seconds to look at the feature and say, no new components, no new data flows, data model doesn't change. That's my incremental done. So maybe there will be 2 or 3 features that require this level of analysis. I think the most agile team can afford this kind of time. The other trick is slightly more sneaky. I said relevant threads. What happened to all the irrelevant threads? Where did they go? Who analyzed them? Now, irrelevant threads. If we were doing this threat modeling from day one of building our application, all the existing threads would be known, and either mitigated or accepted at this point. But unfortunately, we did not. So now I put all the pieces together, but really team wouldn't have all that. And this will be one of the first times, maybe after their training, that's one of the first times when they do something security focused. So the team will be very excited, enthusiastic, wanting to apply the new knowledge, and they will bring up threats that belong to the legacy blob. They will be asking things like, can our registered user inject malicious content? Can anonymous user bypass our access controls and actually modify something in the website? Is our data center infrastructure secure? Maybe attacker can get directly to our database, bypassing web application completely. Can analytics user abuse licensing? How to keep the activity time box, how to keep it focused to just a new feature, to keep it truly incremental. And here I'm going to get a bit controversial. If you go back and do it with your team, you will have to use two phrases a lot. One of them is, we are not making existing situation worse. And the other is, not our problem. Now, it sounds horrible, and it's not the security mindset, right? When we are security people, everything is our problem. Maybe we can rephrase it slightly to say, we don't have to analyze it right now, and emphasis can be on right now, or we don't have to. We will see specific examples in a moment. So these are some of the relevant threats I've mentioned, how we can make them go away. Can registered user inject malicious content? Probably he can. But whatever it is, we are not making it worse with analytics feature. Maybe we are in the hole, security-wise, our whole application. But at least we know we are not digging, right? Whatever it is, whatever is the depth of this hole, we are not digging. The new feature doesn't make it worse. It doesn't increase our security debt. Same for the other one. Is our data center infrastructure secure? Here you have to be careful. We can say we are not making it worse, but you need to be sure you're not making it worse. Maybe the API requires you to punch an extra hole in your firewall, and then you are making it worse. You are increasing your attack surface. So be careful using these excuses. The last one, it's their money. It's their licenses. It's really, really not our problem. Again, there are all sorts of caveats here. So in my story, it was they're told we are going with this provider. But quite often, technical teams are tasked with evaluating and choosing between several providers. If that was their brief, then they would be very much interested in how secure the third-party implementation is. For example, can someone not just abuse licensing, but abuse their whole authentication and get to our data? Should we go with this provider if someone will be able to read our financial information? The exception to the other rule is, if you're familiar with the lean concepts of Kaizen and stopping the production line, in Kaizen there is this idea of undencored. If you see something really disastrous in the production line, everything stops. So if you come something so catastrophic in the legacy blob that it's an immediately obvious critical flaw, then I would say it's an exception to the incremental rule. You really want to inform someone and to fix it as soon as you found it. So we've done it at design stage. What if later implementation deviates from design? This is one of the reasons I always recommend threat modeling to be done as the whole team's activity. It's not just for architect, it's not just for security lead. Everyone should get involved, because when the team shares this mental model, it becomes very easy for them to spot the deviations that are okay, that are within the model, and to distinguish them from deviations that invalidate the model completely. So let's look at this example. First example says, in our model, aggregator was one logical process. What if during implementation we've done a good piece of software engineering and broken it into one will read the data and the other will do the actual upload, which is good. It makes it easier to change the provider later if you want. So if we know that the processes run under the same privilege level, we should see immediately that it makes no difference to our overall data model, no extra attack surface. If they have different privileges, then it's a different story. Let's look at the other scenario. Some manager rushes into the team's area and says, important demo, buyer for our startup, we must have shown them analytics and pretty pie charts and no time to wait for you to implement it. So these nice third-party guys agreed to help us with the demo. If we just give them a set of credentials, they will pull the data directly and we will do it. So hopefully the team that went through this threat modeling knows enough at this point to say this invalidates our model completely. And it may be the management will just accept it, but at least it will be an informed choice. So I say do threat modeling as a team, and not only for developers. If you have in-house QA, if you're doing agile with true cross-functional teams, involve QA as well. QA engineers will be able to derive security test cases from the threat model. They will be able to use it to validate requirements. And it's a really, really good way to develop security-focused thinking in your testing function. Because sometimes we want our testing engineers to start thinking like an attacker, and that's an extremely unhelpful advice. When I moved from software development to consulting, someone told me this consulting joke. So mice were fed up with being eaten by predators and by birds, and they went to consult a wise owl, which is a very stupid joke because owl is a prime predator for mice, but run with it, please. So they said, what can we do? How we can stop all this being eaten business? And the owl thought for a bit and said, you should become hedgehogs. And the mice said, what? How we can become hedgehogs? What kind of advice is it? And the owl said, don't bother with technical details. I'm a strategic consultant. So this is a bit like telling your QA people start thinking like an attacker. That's not an advice that can be turned into methodology and in any practical implications. But if you give them this model, if you teach them stride, that's actually constructive advice. It gives you a scaffolding for doing this threat-oriented brainstorming and coming up with plausible attack scenarios. And based on your threat model, your test engineers will be able to do security testing within the same iteration without leaving it to the last moment pen test. This is where shift left can come from. Speaking of QA, does that look familiar? If you've ever done software development, you've probably seen a similar picture in a book. It says how to deal with untested legacy systems. You can't write all the tests at once, prohibitive investment. You introduce tests around new and changed code, and eventually you get better coverage. And the thinking is, modifications introduce bugs, right? So moving parts, the changing parts of our software are more important than unchanging parts. And from functionality point of view, this is a sound reasoning. If we have a system that's been doing the job for the last 5 years and no one is complaining too much, it can't have that many functional bugs, at least not on the workflows that matter. The problem with it may work for functional. This kind of thinking doesn't work in security. I've collected examples here of famous vulnerabilities, like really famous. They have their own name and logo, theme music, whatnot. But this trend holds for non-famous vulnerabilities as well. sometimes there is an extremely long gap between bug introduced and bug discovered and fixed. So in security, not only what you didn't touch lately can harm you, what you didn't even know you have can harm you. Some of these are code level vulnerabilities, some are design level, some are infrastructure. For example, the drone attack, the idea, if you have a forgotten server somewhere in a corner that supports SSL v2, and all of your other servers are up to date and doing everything right, you're still vulnerable. So something you don't even know you have can harm you. The attacker doesn't care if particular execution flow is popular with normal, non-malicious users. If the code is there and if there is a vulnerability in it, there will be an exploit for it sooner or later. So that's my sting in the tail. Incremental is great, but we won't be able to get away with just doing incremental and chipping off the threads one by one as we modify the system. At some point, we will have to tackle the whole architecture. So we've covered the first reason, right? What we don't know can harm us. The second reason, I can have subsystem A that I've modeled and I know it doesn't have design level insecurities. I have a system B, same, I think it's secure. The way I put them together, I can introduce vulnerabilities. So incremental is good, very useful. Can't get away with just doing incremental. At some point, need the whole picture. So then why bother with incremental? Why not just do the whole thing up front? I think eventually it's better than up front. So first of all, by doing incremental, hopefully you've caught and mitigated some spectacular threats. So when you come to management and ask for time to do the whole thing, you have examples. Should be easier to get time and resources to negotiate the time to analyze the legacy blob. How to tackle the whole thing? It's hard to give universal advice because it very much depends on your organizational structure. If there is only one team, you will have to make time within a team. With multiple teams, it's more complicated, of course, as everything is. Usually, each team is responsible for subcomponent of the system. So not only you will have to make time within each team, you will actually need to set up a working group with representatives from each team talking to each other about the system as a whole. And then when you do that, you definitely want, at this point, for these people who you put together in a working group to have experience of incremental threat modeling, because then they know why they're there. They don't see it as just, oh, they dragged me into another stupid meeting instead of me sitting at my computer and coding something useful. So there is a motivation, there are skills, so this meeting will go faster and will be more productive. And they also have some visibility into their own mini blobs, so you will find better threats. For this reason, I think even if you have the ability to work on your legacy system from day one, it's better, I think, to build up skills through incremental threat modeling. But of course, if you have a complete rollout and you have training and you have time, or you're working on a new system, start straight away. So to reiterate, I think it can fit any time box, even if you're extremely agile. If you're not agile, if you're lean and you're working on one story at a time, even better, do it in the beginning of each story. So the rule of the conference is obviously no sales pitch. I think I'm delivering the anti-sales pitch. If you know for sure that there is no way you will get time to work on the big blob, yes, you can exchange money for time and buy some external expertise to do the initial investment. But if you leave it at that, if you don't continue internal work, keeping it up to date as you modify your system, as you add new features, then this investment is really not giving you a good return. You're missing on 90% of the benefits. It will be just the most expensive piece of documentation you have ever bought. It needs to be evolving system because new features can invalidate threat models, they can introduce new threats. So if you bought external people who've done the model for you and you left it at that, you are missing on 90% of the benefits. You should be using it to analyze new features, to validate requirements, to derive test cases, to promote knowledge sharing within the team. And if you're in a situation where you know how to do it, but you're not doing it because you're waiting for this perfect, magical, shiny new project where you will do it with all the right procedures, then please don't. It's like waiting for a new year to start a new and healthy life. No, today is a good day. It's good for you, but it's also good for environment, because if you're waiting for your new major version, at the moment your current version is out there making people vulnerable. So if it's still alive and you're doing development on it, please do threat modeling. And I say it can fit any time box. Like, guys, if you value an activity, you find a way to fit it into space and time, whatever are the constraints, really, honestly. Hopefully, we've done it in real time with a realistic feature, so I'm not doing vaporware here. We have plenty of time for questions. If you don't come up with question later, you can get in touch, but let's move to questions. Thank you. Do you want to come to microphone?
I can speak loud.
Okay.
So do you think there is a need of incremental threat model if there is just a code change in the application, not design or architecture change? And when do you think a current threat model is getting validated during the software development phase? Is that only just a design or architecture change, or is that any code change can invalidate a current version of a threat model?
I think you can invalidate your model during coding. So you can do a modeling with certain assumptions about design, but when you actually implement it, you can implement it in a way that breaks the assumptions. So I don't know, we said the spoofing threat goes away because we will use mutually authenticated HTTPS, but then you go, oh, I will just use self-signed certificate to save money. That's invalidated your design straight away. And your first question was, do you only do it on big changes? Or?
Yeah, do you need to do an incremental threat model if just a code change, like a function change inside an application? They don't do any design or architecture change?
I think you should do it in every iteration. Even if you look at incoming work to iteration and you quickly go through all the proposed features and you say they don't introduce any new threats, that still you've done incremental threat modeling and you've decided no new threats. I think it's the same with the code review. Some people have rules in code review, only review risky changes. I say it's a silly rule because you don't know if it's risky until after you've reviewed it. So I would say, if you're in an iterative model, do it every iteration. Say in some iterations you only get fixes, small fixes that don't change anything on design level. Fine, you saved time in your planning meeting. You can discuss performance instead.
Hi. So my question would be, can you recommend any other or better method than meeting to resolve and to merge these incremental models? Is there any tool or methodology that you can use?
Technologically, yes, we have a problem if you use this tool that I've used, then they don't merge very well automatically. They're just XML files. You can merge them yourself. We will be discussing this problem in the upcoming OWASP summit. I know the whole industry has this problem. The threat models tend to produce artifacts that are hard to manage later and hard to merge if done by several teams. One way out of it would be put the threads in your main bug tracker. Like, don't start a separate spreadsheet. Spreadsheets are worst. Don't put them in a separate tool. As you discussed a thread, create a ticket in your main ticket management tool. That's the best way. Don't multiply entities. That's the best way for it not to be forgotten. But for merging diagrams, you're right, there is no good answer at the moment.
More questions?
Hi, I was just wondering if you have any tips for distributed teams. How do you conduct stride sessions when you have team members working in different locations? Is there any tips or techniques?
Can they get together for a conference, or are they in a different time zones?
Yeah, different time zones.
Oh, that's tough. Messaging, Slack, I don't know. I mean, if they know the methodology, I think distributed should work because they all speak the same language. So diagrams are tough to build before, like if you don't have any ability to get together. Okay, maybe architecture lead or whoever can build the diagram and distribute it, get comments. Sure, it's more annoying. You have this draft 1, draft 2, draft 3, but then when they agree on the story, then the actual stride session, I think, can be done over chat because all speak the same terminology.
Just a last question to follow up on the question about tooling for threat modeling. Have you ever used Microsoft's tool, threat modeling tool?
Yeah, that's where diagrams come from.
Okay. I'm just curious if you or other members of the audience have experience with other tooling, because geographical spread of teams is a challenge. And so maybe there's a tool out there other people know that they've used. I don't know.
There's an incubator OWASP project, which is a threat modeling tool that I author. So we can talk after if you like. It's called Threat Dragon, quite early stage.
We have time for one more question.
Oh, yes, so the diagrams came from a free tool. You could download it. It's called Microsoft Threat Modeling Tool 2016. And the nice thing about it, the results are in XML, so you can take them elsewhere.
So what you're saying is there's definitely a market for the tool, for some sort of tool to come along, because it doesn't really, in terms of sharing documents. I'm just saying that there's definitely a market there if anyone was interested in it, for a sort of a tool chain to do with sharing threat models.
I think there is definitely a market there for tool for sharing, for tool for being incremental. I think it's one of the topics in the upcoming OWASP summit, the tooling of threat modeling, right? There were some projects. I have seen web-based tool coming from some university project. It wasn't smooth enough for me to abandon the Microsoft tool, but there is definitely room for improvement there.
Okay, thank you, Irene.
Thank you. Thank you.